For years, the United States believed it had found the perfect strategy to slow China's technological rise. If China couldn't buy the world's most advanced AI chips, if Chinese companies couldn't access cutting-edge semiconductor technology, if NVIDIA's most powerful GPUs never reached Chinese data centers, then China's ambitions in artificial intelligence and supercomputing would eventually hit a wall. It sounded like a solid plan. After all, modern AI runs on GPUs. The most powerful supercomputers rely heavily on GPUs. The world's biggest AI companies spend billions of dollars buying GPUs. So if you take away the GPUs, you take away the future. Or at least, that's what many people believed. But what happened next surprised almost everyone. Instead of slowing down, China disappeared from the headlines. For months, even years, there were very few announcements about record-breaking Chinese supercomputers. The United States continued making headlines with machines like Frontier and later El Capitan. Many analysts concluded that the export restrictions were working exactly as intended. Some even claimed that China had fallen years behind. But behind closed doors, Chinese engineers weren't waiting for sanctions to end. They were building something entirely different. Something that almost nobody expected. A supercomputer that didn't rely on NVIDIA, didn't rely on AMD, didn't rely on Intel GPUs. And according to the latest top P500 rankings, that machine has now climbed to the very top of the world. Its name is Lineshine. And if the published benchmark results are accurate, it has officially overtaken America's El Capitan to become the fastest publicly ranked supercomputer on Earth. What's even more unbelievable is how it achieved that milestone. Because unlike nearly every modern AI supercomputer you've heard about, Lineshine doesn't depend on GPUs at all. That single fact has shocked the technology industry. Because for the past decade, GPUs have been considered absolutely essential for high-performance computing. Whether you're training ChatGPT, running climate simulations, designing new aircraft, or researching new medicines, GPUs became the gold standard. Companies like NVIDIA transformed from gaming hardware manufacturers into some of the most valuable companies in history because the entire AI revolution depended on their technology. That's exactly why the United States placed strict export controls on advanced AI chips heading to China. Washington understood something very important. Artificial intelligence isn't just another technology. It's becoming the foundation for economic growth, scientific discovery, military research, healthcare, robotics, autonomous vehicles, cybersecurity, and countless other industries. Whoever leads AI could shape the next generation of global innovation. And AI needs enormous computing power. Limit the computing power, and you potentially limit the AI. At least, that was the theory. But China looked at the problem differently. Instead of asking, how do we continue buying foreign technology? Chinese researchers began asking, what if we simply build our own? That question changed everything. Rather than competing on someone else's hardware, China started investing billions into developing an entirely domestic computing ecosystem. Its own processors, its own networking technology, its own software optimization, its own manufacturing capabilities, its own research institutions. It wasn't a quick fix. It wasn't something that happened in a single year. This was the result of years of investment, engineering, and long-term planning. And now, the world is finally beginning to see the outcome. According to the latest published results, Lineshine achieved more than 2 exaflops on the LinPack benchmark. Now, if that number sounds meaningless, don't worry, let's put it into perspective. An exaflop represents 1 quintillion mathematical calculations every second. That's 1 followed by 18 zeros. Now imagine doing that twice every single second. It's almost impossible for the human brain to visualize numbers that large. If every person on Earth performed 1 calculation every second without ever sleeping, humanity still wouldn't come remotely close to matching what this machine can accomplish. That's the scale we're talking about. And here's the part that makes this story even more fascinating. Unlike most of the world's fastest supercomputers, Lineshine reportedly achieves this performance using approximately 45,000 Chinese-designed CPUs connected through China's own high-speed Lingke interconnect. No NVIDIA AI accelerators, no AMD Instinct GPUs, no Intel GPU clusters, just an architecture designed almost entirely around domestic technology. For China, this isn't simply a technical achievement. It's proof of something much bigger. For years, critics argued that China could manufacture products but couldn't truly innovate at the highest level without relying on Western technology. They claimed that advanced semiconductors would always remain China's biggest weakness, that without access to American hardware, Chinese progress would eventually stall. Lineshine challenges that assumption, not because it proves China has solved every semiconductor problem. Far from it. Building cutting-edge chips remains one of the most difficult engineering challenges on Earth. But what Lineshine demonstrates is that necessity can drive innovation in unexpected directions. When one path becomes blocked, engineers often find another. Throughout history, technological breakthroughs have frequently emerged during periods of intense pressure. Countries adapt. Scientists rethink old assumptions. Entire industries reinvent themselves. China's supercomputing strategy appears to be following that same pattern. Rather than waiting for restrictions to disappear, it accelerated domestic research. Universities expanded semiconductor programs. Technology companies increased investment. Government-backed research institutes pushed harder than ever before. And slowly, piece by piece, the foundations of an independent computing ecosystem began taking shape. Of course, becoming #1 on the top P500 list isn't just about national pride. There's a much bigger reason every major power cares so much about supercomputers. Because these machines don't exist to impress people with benchmark scores. They exist to solve problems that ordinary computers simply can't. And that's where the real story begins. To understand why Lineshine matters so much, we first need to understand what supercomputers actually do. Most people hear the word supercomputer and imagine an extremely powerful version of their home PC. But that's not even close. A gaming computer might have a powerful graphics card and a fast processor. A supercomputer is an entirely different class of machine. Instead of a single processor, it contains tens of thousands of processors working together as one giant brain. Imagine asking one person to solve a million-piece puzzle. Now imagine asking 50,000 people to solve it together, with each person communicating instantly with everyone else. That's essentially how a supercomputer works. It divides enormous problems into millions of tiny pieces, solves them simultaneously, and combines the results in seconds. This is why countries spend billions of dollars building them. Not because they're cool, but because modern civilization depends on them. Every major scientific breakthrough today begins inside a computer simulation. Before a new aircraft is ever built, engineers simulate airflow across every wing. Before a new cancer drug reaches human trials, researchers simulate billions of molecular interactions. Before weather agencies warn millions of people about a typhoon, supercomputers simulate the Earth's atmosphere. Before engineers send spacecraft to another planet, they calculate millions of possible trajectories. Even the artificial intelligence systems we use every day depend on enormous computing infrastructure. Without supercomputers, modern AI simply wouldn't exist. And that's exactly why the race between China and the United States has become so important. This isn't simply a competition over faster hardware. It's a competition over who will possess the computing power needed to develop tomorrow's technologies. For years, America enjoyed a significant advantage. Companies like NVIDIA dominated AI accelerators. Intel and AMD remain major players in computing. American national laboratories consistently produce some of the world's fastest machines. Many believed this leadership would continue indefinitely. But technology rarely stands still. As export restrictions became stricter, China faced a difficult choice: continue depending on foreign hardware, or build an entirely new ecosystem from the ground up. The second option sounded almost impossible. Developing advanced processors isn't something a company accomplishes in a year or two. It requires decades of engineering knowledge, thousands of highly skilled researchers, massive financial investment, world-class universities, sophisticated manufacturing, and perhaps most importantly, patience, because no country becomes a semiconductor leader overnight. Every successful chip is built upon decades of previous research. China understood that. Instead of chasing short-term solutions, it focused on long-term independence. Research funding increased. Semiconductor education expanded. Domestic technology companies accelerated hiring. Government-backed innovation programs received additional support. The goal wasn't simply to replace one imported chip. The goal was much bigger: to build an ecosystem capable of standing on its own. That's what makes Lineshine such an important milestone. Because according to the published specifications, it represents far more than just another fast computer. It represents the result of years of strategic investment. And perhaps the most surprising aspect is how differently it was designed. Today, almost every conversation about AI eventually comes back to one word: GPUs, graphics processing units. Originally designed to render video games, now they're the engines powering the AI revolution. When ChatGPT answers a question, when image generation models create artwork, when autonomous vehicles process road conditions, when researchers train trillion-parameter AI models, they're relying heavily on GPUs. That's why NVIDIA became one of the most valuable companies in the world. Its chips became the backbone of artificial intelligence. This also explains why US export controls focus so heavily on advanced GPUs. Washington understood that limiting access to these processors could slow China's AI ambitions. And for a while, many people believed it would. But Lineshine demonstrates another possibility. Instead of building around GPUs, Chinese engineers reportedly optimized the entire system around tens of thousands of domestically developed CPUs, connected by an ultra-fast interconnect called Lingke. That doesn't necessarily mean CPUs are replacing GPUs in every AI workload. Different architectures excel at different tasks. GPUs remain incredibly powerful for training many modern AI models. But Lineshine proves something equally important. There isn't only one path toward world-class computing. Engineering isn't about copying one successful design forever. It's about finding new ways to solve difficult problems. Sometimes those solutions look completely different from what everyone expected. That's exactly what happened here. When one technological path became harder to access, Chinese engineers explored another. And according to the latest benchmark results, that alternative strategy has produced one of the fastest scientific computing systems ever publicly measured. Naturally, this achievement has sparked debate around the world. Supporters see it as evidence that export restrictions accelerated China's determination to innovate. Critics argue that benchmark leadership doesn't automatically translate into overall technological leadership. Both perspectives contain important truths. A benchmark measures specific workloads under specific conditions. Real-world computing involves many different types of applications: artificial intelligence, climate science, financial modeling, drug discovery, engineering simulations. Each workload stresses hardware differently. No single benchmark tells the entire story. However, benchmarks still matter, because they provide a standardized way to compare engineering progress. They're like the Olympics of supercomputing. Winning one event doesn't mean you're the best at every sport, but it does demonstrate extraordinary capability. And that's exactly why the global technology industry paid such close attention when Lineshine reached the top of the TOP 500 rankings. For the first time in years, a Chinese-built, CPU-only supercomputer had become the fastest publicly ranked system on Earth. That's not just another headline, it's a signal that the global balance of technological capability continues to evolve. And perhaps the biggest surprise isn't that China built a faster machine. It's that China achieved this milestone after many experts believed export restrictions would prevent exactly this kind of progress. Sometimes obstacles don't stop innovation. Sometimes they redirect it. And Lineshine may become one of the clearest examples of that principle in modern technological history. If there's one lesson the technology world has learned over the past few years, it's this: never underestimate what pressure can create. History is full of examples where restrictions, competition, or even crises forced countries to innovate faster than anyone expected. The space race is one example. The internet is another. And today, the race for artificial intelligence and supercomputing may be producing the next great wave of technological innovation. China's Lineshine isn't important simply because it reached the top of the TOP 500 rankings. It's important because of what it represents. For years, the global technology industry operated under one assumption. If you wanted the world's fastest computing systems, you needed the world's most advanced GPUs. That assumption shaped everything. Companies invested billions into GPU clusters. Cloud providers built massive AI data centers around them. Researchers optimized software specifically for GPU acceleration. It became the standard approach. Then China faced a challenge. Access to the most advanced foreign GPUs became increasingly restricted. Many people believed that would permanently slow Chinese progress. Instead, Chinese researchers asked a different question. What if the future doesn't have to follow the same blueprint as everyone else? That question may have changed everything. Because innovation doesn't always mean building a better version of someone else's invention. Sometimes, innovation means finding an entirely different path. And that's exactly what makes engineering so fascinating. There is rarely only one correct solution. Some engineers optimize for raw speed. Others focus on efficiency. Some prioritize flexibility. Others prioritize independence. China appears to have placed enormous value on one particular goal: technological self-reliance. That doesn't mean the journey is complete. Far from it. Building advanced processors remains one of the most difficult engineering challenges in the world. Semiconductor manufacturing continues to evolve at an incredible pace. Every new generation introduces even more complexity. Smaller transistors, higher performance, lower power consumption, more sophisticated packaging technologies. It's a race that never truly ends. And the United States remains one of the strongest competitors in that race. American companies continue leading many areas of semiconductor design, AI software, and advanced research. NVIDIA still dominates AI accelerators. AMD continues pushing high-performance computing forward. American universities remain among the best in the world. National laboratories continue producing groundbreaking research. In other words, this isn't a story about one country replacing another overnight. It's a story about competition becoming more intense than ever before. And competition usually benefits innovation. When one country achieves a breakthrough, others respond. When one company develops a better processor, competitors design something even faster. When one laboratory discovers a new technology, researchers around the world build upon it. That's how progress happens. Each breakthrough inspires another. Each challenge creates another opportunity. And ultimately, humanity moves forward. But perhaps the most impressive part of China's achievement isn't the benchmark score itself. It's the patience behind it. Think about how often we expect instant results today. People expect new technologies every year, new phones every 12 months, new AI models every few months. Everything feels immediate. Yet projects like Lineshine don't happen in a year. They don't happen in 2 years. They're the result of long-term planning. Years of education, years of investment, years of failed experiments. Thousands of engineers solving thousands of problems that nobody outside the industry ever sees. Every processor has to be designed. Every communication link has to be optimized. Every cooling system has to be engineered. Every software library has to be tested. Every tiny improvement contributes to the final result. Most people only see the finished machine. They never see the decade of work behind it. That's true whether the project is in China, the United States, Japan, or anywhere else. World-class engineering always takes time. Looking ahead, the next phase of this competition may become even more exciting. Artificial intelligence continues demanding larger and larger computing systems. Scientific simulations are becoming increasingly detailed. Climate research requires higher precision. Drug discovery relies on more complex molecular models. Space exploration generates enormous volumes of data. Everything points toward one conclusion. The demand for computing power isn't slowing down, it's accelerating. That means the world will likely see even more powerful supercomputers over the next decade. Machines capable of solving problems that today's systems can't even attempt. Some experts believe future systems will combine traditional processors, AI accelerators, photonic technologies, and perhaps even quantum computing. Others believe entirely new architectures will emerge. Nobody knows exactly what the future looks like. But one thing is certain. Countries that continue investing in research today will shape the technologies of tomorrow. And that's exactly why Lineshine has attracted so much global attention. Because regardless of where you stand in the geopolitical debate, it sends a clear message. China is no longer simply participating in the race for advanced computing. It is helping define it. Whether future rankings continue to change, whether another country eventually reclaims the top position, or whether new technologies completely redefine supercomputing, the broader trend is unmistakable. The world is entering a new era where technological leadership is becoming increasingly competitive. Instead of one nation driving every major breakthrough, innovation is emerging from multiple directions. And that's changing the global technology landscape faster than most people expected. The story of Lineshine isn't really about one benchmark. It isn't even about one supercomputer. It's about resilience. It's about adapting when the rules change. It's about turning obstacles into opportunities. And it's about proving that when enough talent, investment, and determination come together, seemingly impossible goals can become reality. The race between China and the United States is far from over. In many ways, it's only just beginning. The next breakthrough could come from a new AI architecture, a revolutionary semiconductor, a quantum computing milestone, or another supercomputer that pushes the limits even further. Whatever happens next, one thing is certain. The future of technology will be shaped by those willing to solve the world's hardest engineering challenges. And if the rise of line shine has taught us anything, it's that the next chapter of that story may arrive sooner than anyone expects. If you enjoyed this video and want to stay updated on the biggest breakthroughs in AI, semiconductors, supercomputers, and China's rapidly evolving technology industry, make sure to subscribe to Byte Dynasty, because the global tech race is moving faster than ever before, and we're here to explain every major breakthrough, one story at a time. Thanks for watching, and I'll see you in the next video.